Bliżej troszeczkę środka. Dobra, dzięki.
Uśmiech.
So, my name is Łukasz. I'm an IT operations specialist in Northern Polska. This roughly translates to being a Unix systems administrator. Today, however, I'd like to talk about the topic of generating text with Perl. First, allow me to take a short trip to the past. What you see here is code sample written in BASIC from roughly 20 years ago, and it's one of those programs that I had most fun with. You see, 20 years ago, most fun that I had was with someone else. I was writing software written in a book. I was learning by copying someone else's ideas. And this idea I found particularly clever. This was a short program that spilled out what is supposed to be poetry, computer-generated poetry. This is the sample output, and as you see, it does its best to emulate human-produced text. How it does this is it stores sets of words in what we would call arrays, and the indexes of those arrays are meaningful. For example, under the second index, you would always find an adjective. There was a specific index in the array for a noun, for a verb, and so on. So it allowed the program to randomly produce an adjective or randomly produce a verb. And what it then did is it used a predefined set of rules that are under those print statements. Those sets of rules stated that in order to produce 4 verses of a poem, you should take an adjective, take a random noun, put them together, always in this order, and by randomly choosing words and putting them in carefully designed places, you would achieve the desired result. So all you needed back then was a set of words and a predefined set of rules, a grammar. And 20 years ago, this was easy. It was also fun, I should add. And the point of this talk, the point that I would have tried to make, is that 20 years later, it's still easy. And furthermore, I will try to prove that it can be useful. So, a trivial example of generating text is simply choosing a sentence at random from a set. For example, this example is from a program that generates text commentary for a chess game. First, it classifies a move as a mistake, and then it wants to tell us that we made a mistake, but in order to provide some diversity, we don't want to use the same sentence every time. So we're choosing a sentence, 1 of 3, and printing it out. But it's not really generating sentences, because the set of rules that we have here is very minimal. We define that an allowed sentence is only one of those 3. Not more, not less. But we can improve on this example. We can make a sub that chooses an element from the list at random, and we can then we can then define those two things that, as I said before, we need. We can define a set of words, adjectives, nouns, verbs, and some words describing frequency. Then we can define a set of rules, or grammar. We can define that a sentence is always an adjective, followed by a random noun, followed by a random verb, and a random frequency word. And together with this random subroutine, we can produce sentences like this. Lazy cow smile red. Whatever that means. Let's try something a bit more complex. Let's try to define a grammar that allows us for some depth. Let's say that we want to write an autoresponder. For example, we want to produce an email that says the same thing each time, but every time it does it in a different way. We want to send a message that says, we are happy that you wrote. And this is our initial statement. At the beginning, we define our message as something that says that we are happy, and something that says that you wrote. This is, I hope that you are familiar with the syntax. It's not any sort of special syntax or something like that, but let's say that we use those straight lines to say that those non-terminal terms need to be expanded. So we are happy is then expanded by a statement that says we are, and a word saying that the same thing that the word happy is. Is it understandable? Okay. So when we have defined this set of rules, we would like to produce output like this one. We want to produce sentences like this. How can we do it? First, we would have to find a way to represent this data structure. Then we will have to write something that will expand our sentences until there are no more symbols with those signs. So all our symbols are terminal. A rough way to do it would be to put it in an ini file. It looks almost the same as an ini file. The only thing we need are those equal signs. So this looks like key value pairs. We need a module like config ini files that allows us to get a set of parameters from a given section as a list. And then there's some other piece of code like this one to expand those sentences when we find non-terminal symbols. This is a hack, and don't do it. There is a better way. I was just trying to get a point across that even if you would try to reinvent this wheel on your own, it's a fairly easy task. But still, when we have a great wheel, there's some point in reinventing our own one. And the tool that I would recommend to anyone who would like to use grammars like the one mentioned above would be the module called inline speed. As you see, the grammar is defined in a very similar way. Every part that is in quotation marks is terminal and is final, and those terms that don't have quotation marks around them will be further expanded until we are left with something that is fully terminal and does not have to be expanded anymore. When we have defined this simple grammar, we can use this fill function and we can produce sentences like the cat sleeps based on this set of rules. So I hope that the first point that I was trying to make is it easy. I hope that I've proven this point enough. But we're still left with the second one. Can it be useful? So, our first example, generating status updates. Let us say that we have two problems. First problem is that someone asks you to provide a status update about an incident ongoing in a production environment, and you're required to provide a status update every 15 minutes. For example, due to an unfortunate company regulation. And our second problem, an even bigger one, is that you don't have any significant information. Still, you're required to post a status update every 15 minutes. There is a solution. Because we can always say something that is usually true. And from my experience, it would be one of those two messages. First message would be something that states that nobody knows what's going on, and I should act yet. But somebody is already doing something. And the second popular kind of message is that someone already knows what's going on. For example, someone has already found the bug, and they are doing something to fix it. You don't know when will it be fixed. And those are the two most common messages I've experienced. Let's focus on the first one. How could we define a grammar to say that nobody knows what's going on yet, and we're doing our best to improve upon the situation? So, how can we say that the status is unknown? Like this, for example. How could we say that somebody is doing something? Like this. And all that's left are some synonyms for we, for solution, and for perhaps the most important term, all is okay. How would we define those? Like this. Again, it's all in the syntax of inline spew, and as you see, those are just synonyms. There's no expansion down here. Those are just ways to divide words. And when you define a grammar like this one, all that's left is the Perl code, which is fairly simple. I've omitted the grammar. I've defined a sub called sentence, which glues those sentences together. I'm creating those two sentences. First one stating that the status is yet unknown, and the second one stating that somebody is doing something to improve it. What's the sample output? There is an ongoing investigation, and the way to solve this is still being determined. 15 minutes later, you can post, investigation is still in progress, and responsible parties are working on a possible solution. In another 15 minutes, you can write, there is an ongoing analysis, and we're working on a fix. As you see, those are examples that are true in most of our cases. And they still provide a great solution to our first main problem, that we are required to post the status update every 15 minutes or so.
Happy users, yes.
Yes, many happy users, and most of them within the management. So the second example. Second example much shorter, because the rough idea, I hope that you get the rough idea right now. So there's no point in defining the whole grammar again. Let's say that you want to generate test data, and you want to generate them for a system that processes mail requests. Someone sends you email messages, for example, containing an SQL query that you are required to run, for example, tonight, or in 2 hours, or at a specific time. And you can expect that this email will always contain the agreed before tag in the subject, and that the content of this email will also be the same, yet there is still space for variety. For example, someone can write a request with a header stating, "Hi, I want you to..." Most of those users have probably pre-configured footer in their email messages. And still, even when we say to them that we need time specification and we need actual query to run, you're still not sure whether they put the query first or the time. So we could define a set of rules for such emails. This is only a sketch. Our email request would be a header followed by an optional white space and followed by what to run, when to run it, and an email footer. But those two parts, what to run and when to run it, can be switched. So we should also provide this as a viable alternative. And for example, those when parts, if our system is complex enough, we have ways to deal with statements such as ASAP, such as tonight, or before 16, after 11, some things like this. So we can put all the allowed samples here, and in this way we can generate messages that are or should be, in theory, acceptable by our request processing system. And in this way, our simple grammar can allow us to produce large amounts of test data for our system. So, just to sum things up, I hope that the point that it's easy, perhaps it's even easier than it was 20 years ago. I hope that this point got through. And I hope that those two examples have also proven that it can be useful. One question that I would pose at the very end, because it's still fun. It's a difficult question to answer because we all have our own definitions of fun. Let's assume that 20 years ago, this program generating poems was fun. It surely was for me. So can we do the same thing in Perl right now? Why the hell not? Simple grammar. Again, just a sketch. First verse, and let's say that the second and fourth are the same in order to write. And provided that we feed the machine with verbs, adjectives, nouns, and so on, we can produce outputs. I like the part about the free beer especially. So, thank you. Any questions?
So the grammar basically introduces a big choice tree where
Yes.
the leaves are sentences.
Yes.
A very subtle thing that might happen if you're choosing one of these leaves, you sort of run down the tree making random choices. And if every choice is uniformly random at each node, you might actually be very unbalanced. If the tree is unbalanced, you will always choose some nodes very often. Do you see what I mean?
Yes, there is a problem with the balancing of the tree.
Yeah.
And this is, I can answer this question in two ways. First one is that it's actually a problem with the definition of a grammar. A well-defined grammar would be balanced. But still, there's a workaround implemented in inline Spew. I haven't talked about it.
Okay.
Inline Spew allows you to assign different weights to some choices. For example, you can say that this one choice should be picked 80% of the time,
Right.
and all the others should statistically be chosen on average in the 1 out of 5 choices. And this feature of the inline Spew model is, for one, it's an added bonus that can encourage us even more not to reinvent the wheel again, because this simple example I provided as an ugly hack doesn't do this. And the second thing that it does, it actually allows us to provide some sort of recursion.
Yeah.
I was talking about this just yesterday. Let's say we want to generate, we want to write down a grammar for some sort of simple calculator. And we define an operation as a number followed by an operator followed by another number. Just a simple thing. How can we define a number? Well, for starters, you can define a set of 15 numbers and then choose a parameter. But you can define a number saying that it's a digit followed, or optionally, followed by a number. So you can say that a number can be two things, a single digit or a single digit followed by a number. And you have the recursion. But you have also a problem that sometimes you add those digits in forever. So you can say that 80% of the time you should stop at the digit and only 1 in 5 should go deeper. In this way, you're not mathematically sure that your program will stop, but in reality it will stop every time.
Thank you.
So, something else? Not. Thank you.